a type of mechanical arm used for various industrial applications. It tenders in movable, programmable, and mechanical body. Mechanical arm which can be programmed, moving part of a machine. Yes. So you can say that there's not a specific definition for robots. Okay, and we can't say that this particular kind of definition can be defined for a robot, but you can say a mechanical, or you can say a component which uses mechanical, electrical, and electronic components which are integrated in a single entity, which can be programmable or non programmable, which can function for a particular specific task, replicating human functions and having some control analogy, is a robotic arm. So, a very generic definition from your definitions I have extracted. Okay, this is something that you all are aligned with, that you think a robot is, and I have made a very generic definition for that. Okay, so now just tell me one question. You all are so much fascinated about robots, that how robots work, how they work in a particular industry, but why a particular robot is required in industry? Can you tell me why a robot is required in industries? To reduce human efforts, yes. To reduce time and cost, yes. Efficiency, reduce time, yes. Safety with efficiency, efforts and time. Okay, okay. Are robots accurate? Are robots accurate? No, it depends. It depends on what? Okay, it depicts approximate. It depends on the parameters that we have chosen. Okay, okay. So, what kind of equipment, or you can say what kind of component, is used to provide the controlled motion to a robotic arm? My question is this. What kind of component is required in robotics to have a controlled motion for a robotic arm? I'm not going to continue until and unless I'll get answers from half of the side. Motor, yes. Only two answers. For today, you need to be very much interactive, because if you are not going to be interactive, then uh, the pace of the program is not going to work. You are not going to get it why you are learning robotics and factory automation. Movable part with some algorithms, great algorithm. Okay, and only three answers. Um, Hitender, Sunidhi, Kalpana, Sahil, Muskan, Ritik, Shubham, Ankur. I need answer from your side also. सो रहे हैं, सब सो रहे हैं. Hitesh.
Sir, can you repeat the question, please?
Yeah, I'll repeat the question. That what is the component that is required in robotic arm in order to move it in a controlled manner or move it anyway? Okay. What is the component that is required in a robotic arm in order to move it? Tools and equipment, sensors, controllers, sensor. Okay. 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 So yes, motors and encoders. Okay. Actuators. Yes. Okay. Uh, all the answers are partially correct, but the most specific answer is actuator. Abhay Kumar PLC. Yes. Uh, yes. Okay. So the most specific answer is actuator. Why it is actuator? Uh, Muskan, can you tell me that why you are saying actuator and not motor or anything else? Yes, actuator is more specific answer. All answers are correct, but the more specific answer is actuator. See, sensors and actuators are a part of a automated system. Okay, and robotic arm is a part of factory automation. A robot is going to be integrated in factory automation. Okay, so there will be a production line, a line will be working, and what you are going to get is that there will be a robot which will be integrated to the factory automation. Okay, so yes, it is the actuator which moves, but actuator has to move in a particular controlled manner. Okay, if you are using a particular actuator, actuator can be of any type, whether it is electrical actuator, whether it is a mechanical actuator, whether it is a hydraulic actuator, whether it is a pneumatic actuator. You might have seen in a robotic arm, you have how you replicate the role of fingers in a robotic arm? There are grippers, right? And mostly the grippers work on pneumatic. Okay, that is also a kind of movement. Okay, so you can't say that everything is controlled by motor. And someone has written that motors and encoder. Yes, a motor and encoder in a combined form will be a servo motor. All right. So you have two kinds of motor. One is stepper motor or servo motor. What you have in servo motor, we are going to get the details of all these type of actuators also one by one. But what you are going to get here is that what is a motor and encoder. It is a servo motor. Okay, so you have an encoder which gives you a feedback about the motion and it works in a controlled manner. Okay. Now just tell me that you have used the topic use of robotic arm in factory automation. Just tell me that what is a robotic arm, you how it is integrated in factory automation. What is the term factory automation? The question is that what is the term factory automation? Robotic arm is a very smaller part, whereas factory automation has a larger aspect. Okay, so the span of factory automation is much more larger than robotics, and robotics is just a part of your factory automation. So can you tell me that what is factory automation? Can you tell me what is factory automation? class, please respond on the chat box. What is factory automation? Please respond on the chat box. What is factory automation? Okay, just respond me the question. Do you know about factory automation? Yes or no? Just answer that. Ritik, automation in manufacturing and developing or developing something. Okay. Process of incorporating the automation into manufacturing process. Okay, okay. So let me tell you that what factory automation is. Okay. So you know about the industrial revolution, that how industrial revolution started. First of all, we used to work with the mechanical components. We used to integrate kinematics into mechanical component, and we used to have a specific outcome, and we called it a machine. Okay. Then we used electrical components. With the advent of electrical energy, uh, we had lots and lots of motors, or you can say solenoids, which were giving us a very specific function. Okay, we introduced electrical energy or electrical energy systems into manufacturing sector. Okay, then what happened was that introduction of electronics. Okay, with the introduction of electronics, there was a major boom in the industrial sector. There was an industrial revolution, and in third revolution, the introduction of PLC came into existence, or you can say introduction of controlling a particular process came into existence, and most of the industrial controlling has been done through PLC. Okay, even your robotics, you definitely have a different controller for robotics, but the factory is automated basically, or you can say primarily on PLC. Okay, so what is PLC then? Please answer this question. What is PLC? I'm just looking at that what kind of answers you are giving. Okay, so I'm just noting that how much you are interested, and all the perks will be according to that only. The more you get involved, whether your answer is wrong, whether your answer is not correct, that doesn't matter. But if you have answered, you are definitely going to get perks for that. And if you are not going to answer, then even I am not going to be much more attentive towards that person, whether it is marks or you can say evaluation or anything. Okay, please be attentive. If I am asking a question, just reply to it. If it is correct, very good. If it is not totally correct, then too also you are going to get attention for that. Okay, so Bhanu, it is a programmable logic controller. It is a computer control system, a small industrial computer for industrial environment. It makes decision based on custom program to control output. Programmable controller for industrial automation control system, a programmable logic controller, or you can say programmable controller. Okay, a programmable logic controller is an industrial computer control system that continuously monitors the state of input devices and make decisions based upon a custom program to control the state of the output device. Okay, a programmable logic control. Okay, so C, yeah, digital computer used for automation. Okay, industrial computer designed to automate control processes. Okay, yes, of course, it is an industrial computer designed to automate control processes. It is a digital computer used for automation that control machine digitally. Okay, a programmable logic controller is an industrial computer control system. Okay, 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 okay. Correct, correct, correct. Sahil, correct. Shubham, correct. Muskan, Aprajita, Shubham Singh, Ankush Singh, Hitesh. Yes, you all are correct. Yes, small industrial computer. Okay. You know about microcontrollers, microprocessors, and PLC. What is the difference between three? Microprocessor, microcontroller, and PLC. Any kind of answer is welcome. Any kind of. CPU on a single chip is microcontroller. Okay. What is a microprocessor then? Okay. So let us start with yeah, microprocessor only CPU, but contains CPU, memory, I/O. Nayan, which one is microprocessor and microcontroller? Specify that differently. ओके, आप मेरे को इस सवाल का जवाब बताओ। चिप पे ही आपकी मेमोरी आईओ डिवाइस लगे हैं तो वो माइक्रो प्रोसेसर है या कंट्रोलर? हाँ। ओके, ओके। अब मैं एक क्वेश्चन सबसे पूछना चाहता हूँ। आपके पास सबके पास लैपटॉप है, सबके पास मोबाइल है, उसमें आपका माइक्रो कंट्रोलर लगा है, माइक्रो प्रोसेसर लगा है। बहुत ईज़ी सवाल है। केवल आदर्श का आंसर आया है? बाकी किसी के में लगा नहीं है क्या कुछ? माइक्रो प्रोसेसर, माइक्रो प्रोसेसर, माइक्रो प्रोसेसर, माइक्रो प्रोसेसर, माइक्रो प्रोसेसर। माइक्रो कंट्रोलर लगा क्यों नहीं है? वेरी गुड, सबका आंसर बिल्कुल ठीक, बिल्कुल ठीक। माय क्वेश्चन इज कि माइक्रो कंट्रोलर लगा क्यों नहीं है आपके लैपटॉप में? माय क्वेश्चन इज व्हाई माइक्रो प्रोसेसर इज इंस्टॉल्ड इन योर लैपटॉप्स एंड कंप्यूटर्स, व्हाई नॉट माइक्रो कंट्रोलर? Yes, microcontroller performs specific tasks. Yes, very limited space for utilization. Very correct. Yes, space required will be more. This is more specific. That the space required will be more. Yes, correct, Ritik. Ritik, you have worked on Arduino, right? Tell me that what is the speed, or you can say processing speed of your Arduino, or you can say Raspberry Pi.
Sir, there is different baud rates,
Yes, there is a different baud rate. Yes.
like 9600, 1,15,200, and various others baud rates are present.
Okay, so what is a range? You can tell me the range, that what is a range, whether it is in megahertz or gigahertz, whatever.
No, sir, I have no
Just
idea that.
yeah, you should know about that also. That what is the processing speed? Okay, so
Yes.
just let me know or let others know about it also. You just go and read that what is the speed for that, and you just come back to us tomorrow. Okay, will you answer that for me?
Yes, sir, surely.
Okay, that
The
what is
speed
the
of an Arduino.
what is the specification of that particular Arduino and what is the speed? That's it. I don't
Yeah,
want another. uh,
yeah, sure, sir.
Okay. Okay. See, and you might all be looking at your microprocessors. You might have seen that what is the speed. Can you tell me that what is the not very correct number, exact number? It is varying with the kind of laptop you have. But what is the processing speed for microprocessors in your laptops or your PCs? What is the range for that? And trust me, these kind of questions are also asked in your interviews also.
1.8 to 3 or 4 gigahertz.
Gigahertz, yes. So please just open your settings on your laptop once and just look at that what is the processing speed. So you might have a microprocessor of Intel or something else, but the processing speed you should be knowing that what is the range for that particular processing speed. And what basically is a processing speed? Can you tell me that what is a processing speed and why it is a particular speed assigned to a particular equipment? A very basic question. Please respond. I need an answer from every student for this question. What defines actually the speed? Even if the answer is wrong, there is no issue. Just try for once that what defines the speed for a microprocessor or even a microcontroller. Please just answer me this question. Yes, how quickly the data can be read, speed at which laptop runs program or complete a task, how quickly CPU takes data and interpret it. So, okay, let me mold my question in such a way that for a microprocessor, if you say that, for example, it is 10 gigahertz, what does 10 gigahertz means? What is gigahertz? Number of calculations done per second. Okay. Okay, let me put a very simple question to you in front of you. Okay. Okay, so just tell me that what is megahertz and what is gigahertz. Now I need this answer from every student. There are 18 students present in this batch. I need answer at least from 10 to 11 or even more than that students. What is gigahertz and what is megahertz? Guys, this is a very simple, yeah, yeah. Only Bhanu and Ritik, please, class, please respond on the chat box. हितेंद्र, कल्पना, सुनिधि, मुस्कान, साहिल, शुभम, नयन, yeah. Okay, so gigahertz is 10 to the 9 power cycles per second, and 10 to the power 6 is megahertz. So you know that there is a piezoelectric material which gives you a bit instruction, and every controller, whether it is used for robotics, whether it is used for factory automation, in microprocessor or microcontroller, it works in a bit to bit instruction. Okay, so how many bit you can operate for a single second, that depends on the type of signal, and that signal is dependent upon the fluctuation that has been generated through your piezoelectric material. Okay, so there is a piezoelectric material. I'm just giving you a very basic answer to that. We will get into that much more in details in the later stage also. But we just need to know that there is a piezoelectric material which provides bits according to the vibration that it has because of an electrical circuit, and that cycle means that this is the number of bit instructions that a processor can process in a single second. Okay, so if there is a bit logic of 0 and 1, then how many logics can it generate for single second? 10 to the power 9 if its processing speed is in gigahertz. Okay, so if it is 10 gigahertz, then it will be 10 to the power 10 cycles per second. Okay, so now just to tell you that yes, a microprocessor is a very single chip, but the it is used for all the memories are and IO card are integrated on a single chip. Yes, for microcontroller, most of the microcontrollers are in the range of megahertz. Okay, the speed is in the range of megahertz. Your, you can say, CPU is integrated on a single chip, and your memory and IO chips are different. But what about PLC? Because when you will go in industries, uh, you are not going to see Arduino or can say Raspberry Pi type of microcontrollers. What you are going to see is PLC. When you will go into shop floor, and when you need to deal with the shop floor, you are going to see PLC. Even if you are going to look at the robots, they will be integrated in factory in a particular line, but they will also be integrated with PLC. So our prime focus here will be on PLC only. We will be getting learned about PLC. Why? Because in industry, it is only PLC where the process is through which the process is controlled. Why only PLC is required in industries? Why not microprocessors or microcontroller based systems? Can someone tell me how it is different from microprocessors and microcontrollers, and why only PLC is required in industries? Class, I need an answer. Uh, okay. Do you know the answer that why PLC is required in industries? Please answer yes or no. What is the difference? Okay. Okay. Let me answer you that. Okay. Okay. See, PLC is used for what industry requires is repeatability, safety, and ruggedness. Okay. What does that mean? That there will be a process, there will be in factory automation, basically there will be a single process which will be continued. Okay, there are not multiple process that PLC is going to handle, because for different processes you will have different PLCs, and or even a one PLC can handle various type of inputs. So for example, there is a single your 1200 PLC, then it can have 14 inputs and 14 outputs. So that depends that how many kind of input and output it is going to work, but it will be not multitasking. It will be not producing many tasks in a single run. It will be just producing a particular process run by run. So time is not an issue as it is in laptops. Space is not an issue as it is in laptops. But the issue is that it should be highly repeatable, it should be highly robust, it should be rugged, and it should be safe. Okay, so what does a PLC, what makes PLC so much safe? That is a very important question. We will go into the in-depth knowledge of PLCs also as a part of factory automation. But the most important thing that you are going to deal with is that why PLC is so much robust, why it is so much rugged, and why it is so much reliable. So in your interview, if you are asked that what is PLC, now can you answer the question that what is a PLC? No, not at this particular stage. And if it is asked that why PLC is used in industries, then you can answer that yes, it is robust, it is rugged, it is reliable, and it is repeatable. But why it is repeatable? Because PLC has been designed for a specific purpose. Now, in you know that in industries there are going to be a huge electrical fluctuation. Okay, but in your laptops you have a very filtered kind of and a very single type of electricity, which is your standard electricity. Can you tell me that what is the standard electricity specification for India? How much volts and how much frequency? 220 volt and 50 hertz. Yes, yes, 220 volt and 50 hertz, and 224 2220 volt AC, alternating current. Yes, yes, correct. Adarsh, Sachin, Ritik, Shubham, you all are correct. Yes, but in industries, is it necessary that you should get 220 volts? For example, if there is a sensor and it is being used as an input for a single logic, okay, so will that logic be of 220 volts? No. Yes. So if there is a load, a single, yes, no, yes. So now just tell me that if in factory you are in charge and you have to control a system which has different kind of inputs, different kind of you can say there is a flow sensor which gives you an analog input. There is a single proximity sensor which gives you a digital input of 24-volt DC, you can say, and in analog you can say that the voltage is alternating, is altering, not alternating. You have a conveyor system where your output is fluctuating. Okay, you have pneumatic system which is working on a electro-pneumatic system where a solenoid is there which is pushing the what you can say your valves, pneumatic valves, in order to change the direction. So there are and different type of input. You need a more, and then even the environment is very much harsh. You can say that there is dust sometimes, there is temperature sometimes. Ritik, one more question for you is that till what temperature, till what temperature does your Arduino processors work? Okay,
Yes,
Arduino
sir.
controllers. Okay,
Yes,
so
sir.
I have two very specific questions for you, and this is not just an exercise. You will also learn because if someone asks, these are the type of questions that are generally asked. Okay, that
Yes,
what is
sir.
the processing speed? At what temperature will Arduino work? Okay, so Ritik will answer this question also. That can I use a Arduino near to a boiler?
Okay, means temperature range only.
We can't. Okay, can Arduino handle the harsh environment of industries?
No.
No. Now you know the answer that why PLC is required and what is different in PLC. Since PLC is only for specific logics, okay, and there is a specified ladder logic that is been assigned to it, it will be working on a very single logic once it is uploaded. Okay, you can change that logic through Siemens TIA portal, but once it is installed for a single stage, there will be only single logic and it will be working rung by rung, or you can say one by one. Okay, so since PLC is for specific applications running on specific logics at a certain time, that makes us available the robustness, repeatability, and ruggedness. Okay, so robust and rugged, you can say that robust means that it is highly repeatable, and for rugged, you can say that it can work in harsh environments also. So it can handle high temperatures, it can handle fluctuations, it can handle different kind of inputs. Okay, but there is a specific PLC for a specific kind of operation. And when you will go to into the industries, trust me, you are going to deal much and much more about factory automation. Okay, so if you are saying that you are interested in robotics, it's a very good thing that you are interested in robotics. Yes, you are. We are going to deal with robotics also, but here the factory automation is the bigger part. Okay, so in factory automation, you are going to learn about how we are going to automate a single factory and how that is going to be integrated in a robot that we are going to deal with. Okay, in the final, what we need to do is we will have the robotic arm. We have a robotic arm facility at Siemens Center of Excellence. Okay, but you don't have a factory automation facility in front of that. What we are looking is that we are going to give you the task for factory automation in front of your robotic arm. Okay, so you might have seen the video of robotic arm of pick and place during your induction. That is why induction was given to all of you. Please answer yes or no. Have you seen that video of pick and place robot? Yes. Yes. So all of you might have seen the pick and place of robot, but how many of you have seen the mechatronic kit? Except for those who have taken the mechatronic class. Have you seen the mechatronic kit during induction program? Just answer yes or no. It's okay if it is answer is no. Kindly respond. Yeah, no issues. Because you are going to learn about robotic arm, and Mr. Ajay is going to teach you about that. You will have different classes for robotics, but you will have your robotic arm facility in Siemens Center of Excellence. What you will not have is a automated system, which is a factory automation system, which you are going to integrate with that particular robot. How you are going to make that system? Does anyone have any idea that okay, robotic arm, you are going to learn about how robotic arm is going to be there, but have you, because it is your internship project, you need to deal with an outcome, and your outcome will be use of robotic arm in factory automation. Now how you are going to make a replica of factory automation at robotic arm? Can anyone tell me that? We have robotic arm facility, we don't have factory automation facility at our center. How you are going to go ahead with that? You are going to get each and every detail about it. Don't worry about it. We will guide you how to make a factory automation setup in front of robotic arm, and how to use that robotic arm with factory automation, because you need to get a whole soul information about the entire factory setup. So just tell me that how you are going to proceed with that. So you now understand that what kind of project you are in. It is not just about robotic arm, it is about robotic arm, use of robotic arm in factory automation. Yes, you are going to get all the information about robotic arm, but what about factory automation that you have skipped? What you are going to do about factory automation setup? Just anything that comes into your mind. We are here to support you. We will teach you each and everything. We are going to go through each and everything. Just tell me that what you are going to do about factory automation. What kind of setup you are going to integrate with it? What kind of setup do you want to integrate with it? Let me remold my question. Please respond. Just I need answers. Class, please respond. Uh, again, Sahil, Ritik, Hitendra, Muskan, Sunidhi, Shubham, please respond to this question. Okay, no idea. Okay. Ritik, don't have any idea about it. Another a few more responses. Whether the answer is no idea, that also works. But I need some responses. No idea, Sahil. Okay, no idea. No idea. Okay, okay, okay. So see, the motive of this, you can say, internship program is you to make you cognizant about robotic arm and factory automation. Okay, and we completely understand that you are quite fascinated with only robotics. That Yes, robotics is going to be very useful for you. You want to pursue your career in front of robotics, but yes, robotics is a very interesting branch. And yes, learning about robotics makes you, and you are going to learn about robotics here, how that robotic arm is going to work. But the main motive is for you to look at the bigger picture also. Okay, you are going to learn about robotics, but you need to understand that how robotics is integrated into factory automation. Where does a robot works in a industrial automation or in a industry, and it is going to be integrated through your factory automation only. So until and unless you are not going to know about factory automation, you are not going to learn about robotic arm. And it is of, trust me, that it is of no use that if you are going to just learn about robotics. Once you are going to be cognizant about all the factors that all the parameters that are being used in factory automation, you will be easily understanding robotic arm, that how to teach a particular arm, or how to use it, and how to integrate it with the, you can say, factory automation. Okay, so now I think that we are on the same page, that you now know that factory automation is a bigger part in industries, and robotics is a part of this. Okay, so yes, robotics is going to be a part, and I wanted to make it clear for you that robotics is going to be a part here. But the most important thing is that you need to integrate it with factory automation, and we are going to integrate this factory automation part. Okay, now what we are going to do in industry automation, that I will answer you once my course is going to get completed. Okay, so now just let me know, let you know about what will be the learning path for you. Okay. Is my screen visible to all of you? Someone please unmute yourself and answer.
Yes, sure.
Okay. So using robotic arm for factory automation. Okay. So for manufacturing or packaging industry, etc. Your learning path for online is defined now, and for offline training you will have 90 hours, and for project you are going to have 180 hours. Okay, and your offline training is not only going to be in robotics domain, it is going to be in robotics, automation and mechatronics domain, so that integration of automation and mechatronics will give you a brief about factory automation, and robotics lab will specifically work on the robotics and how robotics work. Okay, and about your learning path, it is for online session only. Your factory automation is more focused, and it has been integrated with basic robotics. This is the session that I will take. My name is Anuj Sharma, and I will take a 45-hour session, which will not only include factory automation, but it will just give you a basic introduction of robotics also. Apart from that, you are going to have a PLC programming and PLC session, which is been taken by Automation Lab, which is Mr. Suraj Kumar Kamal. And for robotics, for online session only, there will be a 18-hour special session, which will be taken by Ajay Sharma, who will teach you about the teaching and programming of robotics. Okay, so are we aligned on this? Are we aligned on this? Did you understand the structure of the program? Please confirm on the chat box. Okay, so for online mode, because robotics you need more and more of offline training also. Okay, for robotics it is very much important that you should have offline uh, structure, that how it works, how you are going to, you can say, teach it, how you are going to give control to it, okay, through teach pendant. That will be taken by a separate session by Mr. Ajay, okay. Whereas in factory automation, the session will be taken by me for 45 hours, where I will take the basic robotics also. And also, along with that, I'm going to take a session of your, which is going to deal with factory automation. Okay. Now let us come about the project. Your project is use of robotic arm in factory automation. Now we have decided this topic, that factory automation process can be any kind of process, but we wanted to make a little bit simple for you. Okay, we wanted that it should be a little bit simpler for you. So what we are going to give you is a very basic conveyor system. Okay, you know what is a conveyor? Please answer on the chat box. What is conveyor? Kindly answer on the chat box. What is conveyor? Do you know what is a conveyor system in industries? Yes or no? Please answer yes or no. Do you know what is, like in airport for bags? Yes. Yes. Set up to transfer things. Yes. Which is used to replace the object from one place to another place. Okay. That take our initial product to final product. Provide mechanized movement of material. Okay. Mechanical devices to transfer things. Okay. It helps in quick and efficient transfer. Okay. Yes. So what I'm going to do is, yes. A conveyor system is similar to that also. Yes, a conveyor system is used to transfer or thing. It is a belt shape, or you can say chain type, chain and sprocket type structure, which used to transfer, you can say, jobs or workpiece or material from one place to another in a controlled manner or in a continuous manner. Okay, so in this particular session, we are going to learn about the basic anatomy of robots, that how a robot is seen in a mechanical aspect, and about the teaching, Mr. Ajay will give you a very separate session for PLC programming and PLC introduction. Mr. Suraj Kumar Kamal will be taking. But for this factory automation setup, that how this factory automation is integrated, that session will be taken by me. And it is a very important session for all of you to cover. Why it is so much important? Because in fact, until and unless you are not going to get the details about factory automation, there is no need. You can say that there is no, you can say, advantage of learning robotics. So in order to, it is not just about learning, it is also about you to get advantage of robotics. So if you know robotics along with factory automation, then your profile is going to be 100% efficient than just by learning robotics. Trust me, this is a fact, and many students just fall into the fascination about robotics, that we are just going to deal with robotics. But until and unless you don't know how to integrate robotics with factory automation, it is not going to work. So what? Therefore, we have carefully designed this project that it should be used in robotic arm, and it should be integrated with factory automation also. Okay, so you are going to learn about robotic arm also, and also about factory automation. Am I correct? um, are you aligned with this? Please respond yes or no. Are you aligned with this? Yes. Good, good, good. It's good that you understood. Okay. So now I think it is 1.5 hours. How much time break do you need for right now? We'll take a break. 10 minutes or 15 minutes? Class, how much time for break you need? You can answer that, I think. Okay. 15 minutes will be okay? Okay. 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 So it's 15:33. So we'll get back at 15:48 or 15:50. Will that be fine? Okay. Okay. We'll meet after 15 minutes. Okay. 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 I'll be in the session. Okay. You can, if you want, you can leave or you can join. Okay. No issues. Okay. There's a 15-minute break and then we'll join after this session.